Okay, so the first thing that I want to do, I'm still in section 2.3, and there was 2 more questions that I wanted to get taken care of really quickly. We had done almost everything in 2.3, but I wanted to do these last 2, just so that you could see them worked out for you. I didn't worry so much about the 2.3 homework because you can go back to the practice and have a, show me how to work this kind of a thing. But these last 2, I wanted you to be able to see how I would work these. So for number 6, I'm supposed to be graphing. So talk to me about, let's get a description first. And for the record, on your test, there are questions where I say on the show your work page, write out what your description is. And this is what I mean by that. My lab doesn't ask you to do that, but your test is going to ask you to do that. So talk to me a little bit about what a description would look like for this example. So that's not what I mean by description, although that is the case. So you're talking about the square root graph. Wait, which one? And what was it you said, Dylan? X. Which one is it? How come? Yeah, it's on the outside. And remember that anything that's on the outside is going to occur which direction? The other one. Vertically. So this is over the x-axis. Okay, this is a vertical change. So we've got, first of all, reflect over the x-axis. What else? Say it again. I'm not going to accept that for full credit because I have multiple types of stretching. Vertical stretch by 2. Okay, because a vertical stretch looks different than a horizontal stretch. Okay, what else? Okay, yep, right 2 units. And one more thing. Down 1. Okay, so what I'm going to do here is for getting my graph, I'm going to pay attention to the bottom 2 guys first. Okay, now Reed's already told me what kind of shape it is. It's the swoop. He didn't say that, but that's what he kind of motioned with his hand. Okay, so let's take our swoop and let's move it to the right 2 and down 1. Where did the swoop begin on the parent graph? Yeah, at 0, 0. So we're going to take the coordinate 0, 0. We're going to move it to the right 2. And we're going to move it down 1. So here's where our new swoop is going to begin. It's the new origin. Okay? Now, the next thing is when I reflect it over the x-axis, the original guy was up and to the right. What does reflecting over the x-axis look like? Now it's down and to the right. Okay, so instead of a swoop, now it's a swoop. Okay, so I automatically know that I'm going to be from this coordinate here. Let me mark it on the iPad so everybody can see it. From this coordinate, I got to be going down and to the right somehow. Okay, so let's talk next about, again, the parents. Okay, what did the parent do from the origin? Remember I told you that on every graph, you needed to memorize at least 3 coordinates.
I give you really plenty of time. I have a calculator as an instructor that tells me how long it will take in every.
Alicia, if the noise is coming from where you are, you might want to mute your Zoom.
Thank you.
You're welcome. Okay, so what was I saying? Oh, what did the parent do on the swoop? So it started at the origin. Where did it go from the origin? It went to the right. Went to the right 1 and up 1. Why? Because the square root of 1 is 1. Right? And then you go back to the origin. What else did it do? Went to the right 4 because the square root of 4 is 2, so it went up 2. Okay, so you have to keep that in mind as we go and look at our vertical stretching. Okay, so let's come to our graph. If this were a normal parent, and it isn't, but if this were a normal parent, I would go to the right 1 and up 1. I would go to the right 4 and I would go up 2, and I would put 2 new coordinates there. But that's not what this is doing. First of all, this guy is going to go to the right 1 and down because I'm reflecting. And secondly, it's a vertical stretch by 2. Vertical. I'm not changing my horizontals. Okay? If my horizontals started out going to the right 1 and to the right 4, that's not changing. All right? So let's take, here we are, we're at our new origin. We want to go to the right 1. We want to go down. Parent would have gone down 1, but we want to stretch that by 2. So what is 1 times 2? Yeah, so we're going to go to the right 1 and we're going to go down 2. We're going to do double what the parent did. Go back to the origin, that new origin. We're still going to go to the right 4. Now, Daddy would have gone down how far? 2, but we want to do double what Dad did. So we're still going to go to the right 4. How far down are we going to go? Yeah, 4 times, 2 times, yeah, 2 times 2 is just 4. So right 4, down 4. And now I have enough to be able to draw my swoop correctly with a good width. So it's going to look something like that. Okay, this particular question did not ask for domain and range, so we're good on that. Okay, and then we have this guy here, where you are to sketch by hand. You actually, it's not one of our original 6 parents. This is just some random function. Okay, and you see that we're looking at an f of x. Our f of x is the parent here. What kind of parent is it? Like I said, it's just random. Okay, we don't have a parent that looks like this. All right, and so part A says that we want to take our function and we want to do, take a look at it, we want the opposite of the original. Okay, and another way to say that, I can think of 2 other ways to say that. All of my y values are going to turn negative. My x values are staying the same. Okay. Another way to say that, where is the negative? Inside or outside the parent? Outside. And what happens when I have a negative outside the parent? I get a reflection over the x-axis. Okay, so there's yet another way to look at that. Okay, pick one and stick with it. All right, so then if I'm going to, on part A, take everything and make a negative y value, but I'm going to keep the same x value, I'm going to reflect everything over the x-axis. Let's start on the left. How is this guy going to be drawn? Same place, so negative 4, 0. All right, how about this guy up at the peak? How is it going to be drawn? X stays the same, y goes negative. Yep, neg 2, neg 3, so go ahead and put yourself a point there. Okay, if you want to go ahead and connect the dots there, you can. All right, then the next coordinate, 2, 1, what is that going to look like? 2, keep the x value the same, and we're changing the y value, so 2, negative 1. You can go ahead and connect. And then 6, 1, how is that going to be drawn? Yep, and then I'm going to continue on through that. All right, so that's part A, where I'm reflecting over the x-axis. Part B, oh, where's the negative now? It's on the inside of the parent. And so what does the negative on the inside of the parent tell you to do? Reflect over the y-axis. Dylan, what's your question?
So there are questions like these in the MyLab map.
Yep.
How would we, quote unquote, show our work for this?
I can think of a couple ways, like you could just write down the new coordinates that you're gonna graph. That would probably be the easiest way, to just write down the new coordinates.
I was doing a bunch of those and that, and I was like, how am I?
Yeah, I was like, it's like I in the.
Yeah, you got to understand there are going to be some questions that are you're not. I mean, I'm not even showing work, right? And if I'm not going to hold you to a different standard than what I'm holding myself to. Okay, so there are going to be some questions that you just simply cannot show your work. You just have to do it, and I am fully aware of that. But if there's any work at all to be shown, it needs to be shown. Thanks for asking that question. Okay, so I'm going to reflect over the y-axis now, and what that means, take a look, back up here. It's my x value that is changing signs, but my y value is still remaining the same. Okay, my x value is changing signs. So how is this negative 4, 0? How's that gonna be different? It's gonna be a positive 4, 0. And how about negative 2, 3? How is that going to be different? 2, negative 3. Okay, so if you want to go ahead and connect those, you can't. Hang on a second, my brain just got stuck. Not 2, positive 3, not negative 3. Sorry, 2, positive 3. I changed both x and y, okay? So only change the x value, don't change the y value. All right, so I can go ahead and draw that. And then how does 2, 1, how does that one change? Negative 2, 1. And then last 6, 1 will become negative 6, 1. Mine looks larger simply because the grid size is larger, but it's still a switch. All right, letter C then. This time, how do you describe 2 times f of x? What's the description on that?
Is it f of 2?
No. It's a vertical stretch by 2 because it's 2 times my parent. So it's a vertical stretch by 2. All right, so let's go down to point to C. I'll have to zoom in just a tad here. All right, now remember that with a vertical stretch, vertical, okay, I'm not changing my rights and my lefts. What values are rights and lefts? X values. I am changing my up and downs, which is what value? My y value. Okay, so all of the x values that you see on the original here, all of the x values are the same. It's the y values that are doubling. Okay? All right, so what's the first coordinate, starting left to right, what's the first coordinate that I'm going to draw? The negative 4, 0 is going to become what? Yeah, still negative 4, 0. What about the negative 2, 3? What's that going to become? Negative 2, 6. Keep your x value the same. Your y value, your vertical value is doubling because this is a vertical stretch. Okay. What's the next one? 2, 1 is going to become 2, 2. And then last but not least, 6, 1 is going to become so you can even kind of tell that that has been stretched out from top to bottom. Okay. I think there was one more of these. What is f of 4? What is it? F of 4. So 1, 2, 3. There's the x value of 4. What's the y value there? 1. Yeah, 1. Okay. Any questions on that?
This was from last Thursday, right?
Yeah.
Okay.
All right, section 2.6. So I know there was a video on this. I don't remember there being an embedded question. Was there an embedded question here? I just don't remember. And I didn't look it up before I came. Okay. We will see. So on the video, the first thing that I walked you through was getting a prettier version of the question. So that's why the first two that are typed out, those are, you're gonna see those, but really the guy that's in blue, that's the prettier version of adding two functions together. So you're gonna see all of the methods. I'm always gonna rewrite it with a prettier version because it makes it easier. So I did this with adding, subtracting, multiplying, and dividing. On the dividing, why did I give you this little dude that says g of x cannot equal 0? Zeros in the denominator, sorry, I interrupted you. It's undefined. Why is it undefined? Why? Oh man, if we had time, I would go into it, but you don't need to know it for your test. Oh, go ahead. Yeah. Probably gonna want your mask to go out in the hallway. So you cannot divide by 0, and it looks like maybe I even gave you this on the video, where 0 on top is okay because that value is equal to 0. 0 on bottom, no way. And it's undefined. Technically, the reason it's undefined is because it's so huge we cannot define it. It's infinite or it is negative infinity. So anytime you have a 0 on bottom with a number on top, it is infinite. Okay, so that's why we say it is undefined. It's because it is infinite. Finding domain. We're going to keep coming back to these two questions over and over and over and over again. So be comfortable with the two questions. Question number 1, do you have any letters on bottom? I know it says, is there a denominator with a variable? Okay, but the English version of that is letters on bottom. Okay, that's all we care about. Do you have any letters on bottom? And then the second question, do you have any even roots, a square root, a fourth root, a sixth root? Most common is going to be the square root. Okay, in this class, we don't deal a whole lot with fourth roots and higher. So, so for this class, mostly that's going to be a square root. And so we'll talk through what to do with that as we go along. All right, so going for the highlighted ones. Number 1, before I even get started on number 1, according to the video, what's the better way to write that problem right there? What's the better way to write it? F of -5 plus g of -5. Okay, that's what the video said. Okay. Well, now I actually need my two equations. How am I going to find f of -5? Yeah, you just replace all the x's with a -5, okay, in the f function. Okay, so we've got f of -5 is going to be -5 squared plus 3 times -5. And I gotta ask, did I write that correctly? You sure do. And if you don't, you're gonna get it wrong. Okay, I did not write that correctly. What's being squared the way I wrote it? Just the 5. But what's being squared up here? The whole entire x, and the whole entire x is a -5. So you have to be squaring the entire -5. That's a big deal. We talked about that on the first day. All right, so that's just my f of -5. Let's add to that my g of -5. Same thing, 2 times -5 minus 1. All right, follow your order of operations, order of ops. So in the first group, talk to me about simplifying that. So I got a positive 25, and then a minus 15. All of that is that f function, okay? And then let's add to that, clean up the g function, all right? When you clean up the g function, what do you get? Yeah, -10 and a -1 is a -11. Keep cleaning up. First group is going to be beat ya. 10 minus 11, which is -1. Okay. Let's go to example 2. According to the video, what's the better way to write example 2? F of -3.
-3.
Can you say that again, Reed? I missed something.
-3 plus.
It's times, isn't it?
Yeah.
Right, because there's no plus sign in there. Yeah, it's times g of -3. Treat them just one at a time. Okay, so let's go back to the directions and find out what f is. So all of the x's here in my f function are going to get replaced this time by a what? -3. So we're going to have -3 quantity squared plus 3 times -3. And then we're going to multiply that by, go back to the g function, and let's plug a -3 into all the x's for the g function. So that's going to be 2 times -3 minus 1. So again, we're following the order of ops. So in that first group, what are you doing here? What does that become? 9 plus -9 or 9 minus 9. Oh, what's that going to become? And what's 0 times anything? Okay, so spoiler alert, the answer is 0. Okay, this guy over here, we'll just finish it out. -6, -1 is going to be a -7. But either way, it's just going to equal 0.
So would you, I guess, really have to show
What do you mean by all that? Because I still skipped some stuff.
yeah, and, like, I don't, how detailed do you want the work to be?
You're not going to like my answer. Mm-mm. So the deal is, when I'm grading, when I know there's a question that work needs to be shown, and I'm going through, if I can't tell how you went from one step to the next, then it's not enough work.
That's clear enough. I thought, like, I would have had to, like, maybe do, like, -6 minus 1.
No, the amount of work that I did now, if you are in my Math 101 class, then yes, okay? But not in Math 110, not at this point, okay? But if I cannot tell how you went from one step to the next, at that point, this is where we have issues. This is where it falls apart. Good question. All right, number 5. Find the following and find the domain. Okay, so guys, here, by the way, we're still using the same f and g functions. Here's where you need your 2 questions on domains. So I believe this is on 2 separate pages. So you're going to need to go back in your notes and find, use those 2 questions on domain. So have those handy because we're going to be using them right here. First thing for example 5, what's the better way to write f minus g of x? F of x minus g of x. Okay. Now this time, this one's different because I don't know what my x value is. All right. So the first thing I'm going to do is, do you know what f of x is? You don't? Doesn't that say f of x equals? So you do know it, but it was a ways up there, wasn't it? Yeah.
I thought we were a different question.
Well, no. So what is f of x? X squared plus 3x. So let's come down here and in for f of x, let's substitute x squared. What was it? X squared plus 3x. Okay. Minus. What's my g of x? 2x minus 1. And now I didn't scroll back up, okay, but that is what's in the directions before the first couple of examples there. So 2x minus 1. What do I do here? Okay, so I'm going to be distributing the negative. I'm just combining like terms, right? Because this is all adding and subtracting. So I'm just combining like terms. Are there any terms that are in x squared? Just the one, right? So x squared it is. Are there any terms that 3x can be combined with? Yeah, but close. It's really not a 2x. What is it? It's actually a negative 2x because that negative has to be passed to the 2x. So it's actually a positive 3x minus a 2x, which gives you a what? What kind of an x? A positive x. Yeah, it's a 1. Okay, and then what's the only other thing that's up there that I haven't messed with yet? That 1 up there. Now, what kind of a 1 is it? Why is it positive? Because again, this negative has to be, everything inside has to be the opposite of, right? Remember, minus means opposite of? Okay, so it's a minus negative 1, so that's going to be a plus 1. What's that? Yes, trinomial. Now, okay, what are the 2 questions on domain? Because my directions said not only should I find the new function, but that I should also find the domain. So what's the first question on domain? Is there a denominator with a variable? English version, you got a letter on bottom? No. Okay, so I don't have to worry about that one. What's the second question on domain? Somebody else? Do I have an even root? Yes or no? No, I do not. I have a square, but I don't have any square roots. Okay, so then if both of the answers to those is no, what's my domain? All real numbers. Negative infinity, positive infinity. And basically what we're saying here is that you can plug in any x value you want to, and it's not going to cause any problems. Okay, that's essentially what this is saying. All right, let's go to number 6.
On the test, if you want to write all real numbers or the negative.
Usually in my lab, domain and range are required in interval form. So I don't mind in class when you tell me all real numbers, but my lab won't accept that. Typically. All right, so on number 6, what's the better way to write number 6 according to the video I gave you? Okay, so f of x divided by g of x. Okay, do you know what f of x is? Okay, so let's put that up on top. So we got up on top, x squared, was it plus 3x? Okay, there's my f of x. And what goes on bottom? 2x minus 1. Now, just like with the last question, if we can simplify, we need to simplify. Can we simplify? You can't. You cannot simplify. There's nothing you can do. Nothing. Okay, there are not identical factors. You can only cancel out identical factors. Factors are things that are multiplied together. There's no identical factor. You cannot, there's nothing you can do. This is the answer. Okay, so if you are thinking that you want to do something else, this is a problem. You can't do anything else. Okay, but we do need to go find the domain. So let's talk about the first question on domain. What's the first question? You got a letter on bottom? You do? Okay, so now you're looking at that question. So let's take it further. If you have a letter on bottom, what does it say to do? What's not equal to 0? The denominator. So what we're going to do is we're going to write down the denominator. What's my denominator up there? 2x minus 1. And we are going to make it not equal to 0 because my denominator is not allowed to be 0. Okay. Now, at this point, pretend that that's an equal sign and solve. Solve for x. Okay, so what are you going to do to solve for x? And add 1, divide by 2. So you're going to end up with an x does not equal. There's your adding 1, and there's your dividing 2. Okay. Now, there's 2 ways to write domain. And you're just gonna have to pay attention to what my lab is asking for. On this one, it's actually really easy to use set builder notation. Okay, remind me, how does set builder notation start out? Curly bracket, and what goes on the inside? X such that. Now you ready for this? Because if you blink, you're gonna miss it. Take this guy, and this is what's gonna go, this is my description right here. X such that X does not equal 1/2. Okay. That's one way to write it. You're just gonna have to follow the directions on my lab, because if my lab says write an integral form, this doesn't fly. All right, so let's talk about integral form then for a minute. Let me just draw you a picture. Basically what we're saying is that you're allowed to choose any X value in the world that you should ever want, except for 1/2. That's the only X value you cannot choose. So if this is the one X value that I'm not allowed to have, but I'm allowed to have any value to the left and I'm allowed to have any value to the right, how do I write that in interval form? Now I need some symbols on that. What kind of symbols do you want to use on the 1/2s? Square bracket or round parentheses? Parentheses. Parentheses. Why?
Because you're not actually using it.
You can't use it. We just said you cannot equal that one. Okay. Question, Devin?
Isn't X equal 1/2 just an asymptote?
Mm-hmm. But an asymptote is a place where my X values cannot be equal to anything on the, remember an asymptote is no man's land. You're not allowed to touch it. Okay. You're not allowed to touch it because X can't equal it. Yeah. Okay. All right. So that's domain then for using one of your domain questions. All right. New f of X and g of X, a new one. Easier way to write number 7? Mm-hmm. Let's plug and chug. What's our f of X that we can plug in? Okay, plus, what's my g of X? Okay. Can I simplify this at all? Can I make it any easier?
Take out 4x squared.
Mm-mm.
Simplify it.
No, you can't. So the suggestion was, can I take out the 4x squared and take the square root of that? You cannot split apart addition and subtraction underneath a square root. For instance, no. You can only multiply on both sides by 2.
Yeah, it's running.
No. Because you didn't mean both sides. All right, going back, Devin. If your theory works, what would the square root of 25 be? You know what, forget this 25, let me change that into a 16. What's the square root of 16? What's the square root of 9? Okay. My theory is you cannot split them up for adding and subtracting. You actually have to work the group first. What's 16 plus 9? 25. So this is the same thing as square root of 25. And what's the square root of 25? Yeah. So these two, you can't have both of these for answers, right? So the rule is that for adding and subtracting, you cannot take square root piece by piece. You can do that with multiplying and dividing, but not with adding and subtracting. Okay, does that make sense? Okay, so now back to you, Dylan. It wouldn't make any sense to take this side and multiply it by 2. Because I don't want to know what that side is multiplied by 2. I want to know what f plus g of x is.
Oh,
Okay, so the bottom line, guys, there's nothing you can do with this. It's as simple as it's gonna get. Okay, so let's go to domain then. Domain questions. Question number 1 is, you got a letter on bottom? Nope. What's question number 2? You have an even root? Oh, yes, I do. What does your notes tell you to do when there's an even root? Okay, hang on, Reed. Take the inside. What's on the inside? 2 plus 4x squared. Reed, what am I supposed to do with the inside? What's it say? How'd you lose that page?
If this inside root of root positive 4 equals 0, and the inside is greater than or equal to 0, then solve for x.
Okay, so make it greater than or equal to 0. Now, this one, I'm actually going to work this one logically, and then I'm going to come back a little bit later and do a different question. But logically, I want you to pick any number in the world that you want. It can be positive, it can be negative, any number in the world that you want. Okay, you got one in your head? Everybody have a number? Square that number. Okay, now, for every single person in this room and for every single person who has joined me virtually, if you square any number in the world, what kind of number comes out? Positive. Because a positive times a positive is a positive, and a negative times a negative is also a positive, right? So no matter what number you've chosen, we're all sitting with a positive number in our hands. All right? Now take a look at that guy up there. You got a positive number for this. Now take your positive number and multiply it by a positive 4. Now what does everybody have? What's a positive number times a positive? Still positive. Now take your positive number and add 2 to it. And what does everybody have? Still a positive. My rule here is that everything you have has to cause a positive number. Greater than 0 is a positive number, or equal to 0. Okay? Well, guys, it doesn't matter what number you choose. It's always going to come out positive. Always. Okay? So then what would we say our domain is if every single number in the world does what it's supposed to do, what's my domain? All real numbers, negative infinity, positive infinity. Okay. What's the better way to write this guy?
The last one was 2 plus 4x squared is greater than or equal to 0. How is the numbers less than 0? If it's the domain is supposed to be all numbers greater than or equal to.
So Reed, what number did you choose when I told you to choose a number? 4, or can you choose a negative 4? No, I'm telling you to.
Negative 4.
Okay.
Negative 4.
And what happens when you square a negative 4? It becomes a positive 16, right? And what happens, Reed, when you take your positive 16 and you multiply it by a positive 4? It's still positive. And now take that positive large number and add 2 to it. It's still positive. So it doesn't matter what number you chose, any number from negative infinity to positive infinity, when you square it, it becomes positive. When you multiply it by a positive, it becomes positive. And when you add a positive, it's still positive. Does that make sense? Okay. All right, so what's my f of x then? Let's plug that in on top. And on bottom? Okay, so domain. What's the first question on domain? Letter on bottom?
Yes.
Yeah. Oh, what's my rule say? The bottom cannot equal 0. So let's write that down. The bottom is x. it cannot equal 0. Now, there's no simplifying to do with that. That's already simplified. Okay. What's the second question for domain? Do I have an even root in there somewhere? I do. Now, we've already done this once, so I'm not going to go through the process all over again because we've already done this one. But for that second piece, I'm just going to put a semicolon in here. That second piece, you already told me that when I have 2 plus 4x squared greater than or equal to 0, that happens no matter what. Okay, now we have to put these together. Okay, where on this one, I know that x can be any number in the world, right? So if x can be any number in the world except for 0, okay, then how am I going to write that domain? I can have any number in the world I want to except for an x value of 0. Negative infinity to 0 symbol, parentheses, and then union. What else? 0 to infinity. So any number in the world I want, except for the number 0. Okay? I'm going to come back to that concept. I got to get some other stuff done first, but I'm going to come back to that concept. And I'll do one more of those that has a square root in it, okay? All right. Hopefully. Okay, use the table to find the following. I'm not going to do all 3 of these. Let's do A and C. Okay, A and C. Now, before we even pay attention to the table, what's the better way to think of part A? F of 2 plus G of 2. And now that I have them separated, go to your table and let's figure out what is F of 2. What is F of 2? Yeah, it's 5. Because here's my x value of 2, and I want f of, so this is where I'm going to use f of 2 is equal to 5. So let's plug in f of 2 is the same thing as 5. Plus, what is g of 2? 4. Add. Yep. These are almost so easy that students tend to miss them a lot. It's like, this can't be as easy as it seems. Okay, let's go to part C. What's the better way to write part C? Is this a problem? Should I just go ahead and write undefined? Yes, no, maybe so. Let's find out. Okay, go to your table. What is f of 0? 8, so let's plug that in up on top. What is g of 0? Oh, that is totally legal. I don't need to throw that out. 8 divided by -1 is -8. Yep. It's one of those where students tend to jump the gun and say, oh, can't do that, move on without actually thinking through it. Okay, so take the time to think through it. All right, composition. Composition. Let me zoom in on this. Can you see that these are open circles in between here? Hopefully, does that show up on your notes as an open circle? It's not a time sign, okay? It doesn't say fog, okay? But it just says F of G. That's how we read that. This one I'm really gonna be a stickler on as far as rewriting it, okay? Because let me tell you, what's written there in that magenta color is the easiest way to look at this. Because when I see it written like that, I can follow my order of operations, okay? So we always, always, always want to rewrite composition. Okay, so, and for the record, the way that you read it, you've got F of G of X. Okay, so this is how we read it. That says G of f of -2. Yes. All right. So let's rewrite number 10. Dylan just said it, or almost all of it. So G of f of -2. Okay, talk to me about the order of ops. What's first in order of ops always? Yeah, the inside, the parentheses, right? Okay, or I like to call it the groups. Okay, that doesn't fit in very well with, please excuse my dear Aunt Sally. She and I have some arguments about some stuff, but nonetheless, I like to go with groups. Now, the innermost group is the -2, and you can't do anything with just the -2. So you're moving out just a little bit. I can do something with f of -2. How do I find f of -2? Plug it in for what? In which equation? In the f equation. Okay, so leave the g alone because I'm not touching it. F of -2, how do I rewrite that? No? -2 squared. Thank you. There has to be parentheses there. Keep going. +3 times -2. So it's taking your whole entire f function and plugging a -2 into all the x's. Okay, now let's clean that up. I still have a g. I still haven't touched the g. Okay, so you can't forget about it. If you clean up what's inside, what's the first term become? 4. What's the second term become? All right, so you've got a 4 minus 6, which is going to be g of -2. Let me just stop right here. Just because I came up with the same number that I started with doesn't mean that always happens. It doesn't. It's rare, in fact. Okay, so don't fall for the trap that says this always happens. Okay, well, now what is it that I'm looking for? G of -2. So let's go to the g function. And let's plug in a -2 for all the x's in the g function. Now, I don't have to write g anymore because I'm about to apply the g function. So how do I write the g function with -2 in it? Okay, and we clean that up. -4 and a -1 gives you -5. Let's do the exact same question, only instead of having a number to plug in, let's leave the x to be plugged in. Okay, so this time around, it's the exact same thing, only I don't have a number. What's the better way to write number 11? Yep. So g of f of x. Order of ops says we start on the inside, right? What's on the inside? F of x. Do you know what f of x is? Yes, you do. It's in the directions. What is f of x? All right, so f of x is going to get taken out, and I'm going to replace it with x squared plus 3x. Don't forget to leave all the stuff around it there. You haven't messed with it yet. Okay, let me stop right here for just a minute, okay? What I'm going to do next is going to be a little tedious, but it works. So a lot of times students don't want to do what I'm about to say, okay? And if you get it wrong, I'm not going to feel sorry for you, right? Okay, so notice that it says G of all this junk. You agree? Okay. Yeah. So if I asked you to do G of 2, what would you do? And what would it look like? What would it look like if I plugged in a 2 for all the x's? If I wanted G of 2, what would that look like? 2 squared plus 3 times 2. Okay, that one's too pretty, that one's too easy. I don't want to do that, that's boring. So let's do G of face mask. If I wanted G of face mask, what would that look like? Face mask squared. Good, plus 3 times face mask. Okay, I don't want G of face mask. I had it up to here with face mask. Okay, I want G of ugly. So it would be ugly squared. No, that's really ugly. Ugly squared plus 3 times ugly. Now, would you guys all agree with me that what I'm looking at up here is G of something ugly? It is. It's not pretty like G of 2, right? It's G of something ugly. So you just told me that G of ugly would be ugly squared plus 3 times ugly. I'm going to write that, only instead of writing UGLY, I'm going to put an empty set of parentheses every time I say the word ugly, right? So you said ugly squared, all right? So I have parentheses, that's my ugly, squared, plus 3 times ugly. And where do I get my ugly?
2x minus 1.
And no. I just messed up. I was on such a kick. I just messed up. Erase that. Erase that. Erase that. Erase that. I messed up the whole thing. I want to get done. Not done with time, but I got to get through this section. Okay, sorry guys. Okay, did I remember me talking to you about how this is a safe place for making mistakes? I just made a major mistake. Okay, don't do that. Don't act like me on the test. I'm sorry. Okay. Miss Roberts messed up. After 24 years, she still can't do math. Okay. All right, back it up. You guys, all of you should be looking at me the whole time going, but Miss Roberts, that's not G of 2.
Yeah, it's
But nobody stopped me. I'm not blaming you though. It's my mistake.
I thought I knew where you were going, but.
It's my mistake. Okay, so nothing like having to restart the problem. I want G of. Sorry, Zoomers. I messed up. G of. Try it again. What's G of 2? What would it look like? 2 times 2 minus 1. What's G of face mask? 2 times face mask minus 1. What's G of ugly? 2 times ugly minus 1. Here we have a G of something ugly, right? So you said that G of ugly was 2 times ugly minus 1. So let's write that down. 2 times ugly minus 1. Okay? Now, what goes in for ugly? What was it that was so ugly in the line above? X squared plus 3x. That's my ugly, so let's put it in. X squared plus 3x.
I was making something a lot more ugly.
Oh, really? All right, so can we clean that up then? Yeah, so let's distribute the 2. What do you get? And then that minus 1 is just hanging on, isn't it? Okay. Did I have to find domain? No. I hope there's another one of those so I can make up for my mistake. What's that? All right, so the next one, 2 new functions. 2 new functions. And this time I'm supposed to find and get domain. Find and get domain, okay? So let's find first. What's the better way to write number 12? Of G of X, good. What's the piece I know? Start on the inside. I actually don't know x, but it's g of x that I do know, right? So let's take out the g of x. What does g of x get replaced with? Negative 5x plus 2. Now, don't forget the stuff around it. You haven't used that yet. Okay, I'm doing this one right the first time. See how it says f of something? Okay, what would f of 2 look like? 9 minus 2 times 2. Okay, that one's boring though. What would f of keys look like? 9 minus 2 times keys. What would f of ugly look like? 9 minus 2 ugly. Okay. Well, this one is f of something ugly. So it's 9 minus 2 ugly. What's ugly? The negative 5x plus 2. All right, clean it up. Have you cleaned it up yet?
9 minus negative 10x plus 4.
So instead of writing 9 minus negative, may I write,
9 plus
yeah, plus 4
or minus 4.
or minus 4?
Yes, minus 4.
Why?
Because it's negative 2 times
Minus 4. You're going to leave it like that? Combine your like terms. What do you get? 10x plus 5. Domain? What's the first question on domain? What are we looking for? Letters on bottom. What's the second question? Square root, right? Even roots. Don't have either one of those. So if I don't have either one, what's my domain? Okay, let's go backwards. Hey, do you think if we go backwards, they're the same? You know, kind of like an A plus B is the same thing as B plus A. Do you think that f of G is going to be the same thing as G of F? No, it's the same two functions. I'm still using those, the F and G above number 12. So it's the same two functions. Well, let's find out. You think it's a trick question? Let's find out. Okay, so G of F, let's write it better. G of F of X. Start on the inside. So what's your F of X equal to? 9 minus 2x. I'm trusting you because I didn't go back and look. So we're taking the F of X out. We're replacing it with 9 minus 2x. Okay. Now, do you see that I have a G of something, right? Okay. So let's go back up. I do want to go back up now. So G of, here, let me do it on the iPad. G of equals what? Negative 5 plus 2. Okay, so we got that down. So we've got here, and I spit all over my iPad. That's kind of gross. So I guess that's not good for the coronavirus, is it? I don't have it. Or at least I don't think I do. I haven't. Oh, okay. Let's keep on moving. What was it then? I totally lost my train of thought. Negative 5 plus 2. All right. So negative 5. There's my plus 2. And what goes in for that? 9 minus 2x. Okay. So let's clean it up. Got negative 45. Keep going. Okay, and then if I combine like terms, I have 10x Were they the same? They weren't. Okay, so we would say then the mathematical way to say that is that composition is not commutative. Commutative properties where you can trade them and it's the same thing. Composition is not commutative. All right, what's my domain here? All real numbers. I'm going to change the next question. Okay. So if you have printed notes, we're not going to do this one. I'm going to change f of x. I'll leave g of x the way it is, but I'm going to make f of x equal to the square root of x plus 7. Okay. Because I told you that I wanted to revisit domain on a different type of square root. So this is what I'm going to do on this one. Okay, that's why I'm doing that. So let's write it nicely first. G of f of x. Do you know what f of x is? Square root of x plus 7. Okay, let's come back up to g. What would g of 2 be? 2. What's g of ugly? Ugly. So here I have g of ugly, which is equal to ugly, right? So that's just going to equal the square root of x plus 7. Find domain. You have any letters on bottom? No. You have any square roots? Yes. Okay, so you might need to go back to that question again in the notes. What? It's an even root. It's an even root, square root. So when you have an even root, what did the notes tell you to do? Inside, let's stop right there. What's the inside? X plus 7. All right, keep going. You're going to take the inside and set it equal to 0, or there's more, greater than or equal to 0. Because remember, inside a square root has to be all positive numbers or equal to 0. And then I'm going to solve. Okay, so how do I solve that little guy? Subtract 7. So all of my x's have to be greater than or equal to -7. All of my x's have to be greater than or equal to -7. Okay, there's 2 ways I can write this. If my lab lets me write it in set builder notation, we got x such that, and just copy what you've got up there. X is greater than or equal to -7. But if my lab asks you for this in interval form, think about all numbers that are greater than or equal to -7. You should be picturing a number line in your head right now. All numbers greater than or equal to -7. Okay, so how would I write that in interval form? Okay, so square bracket -7, that's my equal to. And then from -7 all the way to positive infinity. And really, my lab almost always requires interval form for domain. Okay. I'm going to skip number 15. If I have time, I'll come back to it. I want to get to the graph. Use the graph to evaluate. Okay, so let's take part A here. I'm going to write it up here. What's the better way to write part A? F of G of 2. Now, Hopefully you're not, if you are colorblind, I hope you can see the difference between red and blue, okay? If you're not colorblind, then we're okay. What's that? What, can you see the difference between the red and the blue?
Yeah, I'm talking about
Oh, your print is colorblind. I totally agree. And when I used to print out tests, I would run into the same problem. So in this case, and the nice thing about giving you a test on my lab, you have colors on your screen, so I can keep it just like this. I don't have to do anything special. Which graph is the G graph? Yeah, the red one, and the blue one is the F graph. So where in this do I begin, with the F graph or the G graph? The G graph. We're starting on the inside. So we want G of the X value of 2. Okay, so the X value of 2 is right here. What's the Y value? And remember, we're looking at the G graph. The G graph, the red graph, is -2, right? So here's the corresponding, let me change colors because it matches too well. Here's the corresponding point for the G graph at the value of X equals 2. Right? And so this is the coordinate 2, -2, the Y value then, this is a -2. If I'm copying the stuff around it, now I want F of -2. So now I have an X value of -2. So I'm gonna go this way. There's the X value of -2. What is the F function value, the Y value on the F? Yeah, that's going to be down here. So this is -4. I don't need the F anymore. I just found out what the F was. What's wrong, Justin?
Where'd you get -2 from? Is it from the Y value of that graph?
Of the red graph.
And then you use that to find the other one?
Mm-hmm.
Okay.
Let's do one more. Let's do part B. G of F of 4. Let's get rid of all this junk. All right, Justin, what X value am I focused on? 4, okay, so the X value of 4 is right here, right? And I want F of 4. So do I want to look at the red Y value or the blue Y value? The blue one. No, they end up being the same thing, but still, I want the blue one, right? Okay, so what is the blue Y value? Okay, so F of 4 is the same thing as 2. Okay, copy the other junk around it. Now, Justin, what X value am I focused on?
The 2.
The 2, okay, so let me move this junk. Here's my X value of 2. Do I want to pay attention to the red Y value or the blue Y value at 2? How come? Because it's G. And what is the red Y value at X equals 2? -2. Does that help?
Yeah.
Good. You're welcome. Thank you for picking on you.
I know it helped.
Good.
It's fine.
Good. Okay, so let's go back up to this one that I skipped.
Wait, that was it?
Yeah. I could use a picture like this and go, you remember the table that we did a few minutes ago where it was like an F plus G of something? I could do the same thing here with plus, minus, divide, multiply, okay? I could use a table for composition, right? So I could use that table, and instead of making you do F plus G of 0, I could make you do F of G of 0. Okay, so the tables and the graphs, they're basically the same kind of problem. Okay, go back up to number 15. What's the better way to write number 15? G of X. Okay. I start in the inside, right? So what's G of X? on the inside? 1 over x squared. Now don't forget to plug in all the stuff around it. Okay. Now I could say, what's g of 2? What's g of pencil? What's g of fish? I think those are fish. What's g of ugly? Oh, look, I've got a g of ugly up there on the board, right? So as I'm looking at my original, what is g of ugly? G of ugly equals 1 over ugly squared. 1 over ugly squared, right? Okay, so let's do that. 1 over ugly squared. What's going in for my ugly? That guy up above it, right? 1 over x squared. I'm not even touching the f function because I never had an f in my problem.
So that's what, like, triggers what it says.
Okay, so can we clean this up? Remember, to square a fraction, all you have to do is square the top, square the bottom. So I've got a 1 on top. Over, all right, what's a 1 squared? 1. And what's an x squared squared? X to the 4th. Okay. How do you divide fractions? What's the rule for dividing fractions?
You have to flip it.
Yeah, so some people say you multiply by the reciprocal. Some people say invert and multiply. Some people say drop, change, flip. Whatever works for you is fine. Math 110 is not where we learn that, okay? It's just where I remind you of that. So let's take my bottom fraction, flip it over, and multiply by the top. So you have a 1 on top times the reciprocal. So a 1 on top times the reciprocal, x to the 4th over 1, what does this become? X to the 4th. Now, the reason that I wanted to make sure I came back and did this question is I want to look at domain. Okay? Domain. First question, do you have any letters on bottom? Well, not in your answer. But did you have any letters on bottom in any part of the problem? Yes. And so if you did, you still have to include those. Because what happens is that way up here inside the problem, it was undefined before I ever finished up. It could have been undefined before I ever finished up. Okay? So anywhere in the problem, what was the bottom that had a letter in it? An x squared or even an x to the 4th, but that's fine. And what does your domain tell you to do if you have a letter on bottom? You take the bottom and you do what? Set it not equal to 0. So we're saying that x squared is not allowed to equal 0. We could say x to the 4th is not allowed to equal 0, but that's saying the same thing. Okay? And solve. So if x squared is not allowed to equal 0, what do we know about x? X is not allowed to equal 0. I mean, if you really want to, take the square root of both sides. The square root of 0 is 0. Okay? If that'll make you feel better. Okay, how do I write that in an interval?
Square bracket 0 something.
You guys agree with them?
Or not, I mean, parentheses.
Why is it a parentheses read and not a square bracket? Yeah, I'm not allowed to use it, right? Yeah, good catch. Good catch.
So where did the x squared and the x come from again when you wrote that?
Where did this guy come from first? Well, is there any place in the problem where I have an x on bottom, a letter on bottom? Yeah, so then I take the bottom and I set it not equal to 0.
But it doesn't matter if you use like x squared or x to the 4th.
I can use both of them. Either way, I'm still gonna end up with, when I solve, x does not equal 0.
So why is it just like regular X and X squared?
We have to solve. The first one,
Oh,
right? Because that's what the domain says, solve for x. Yeah,
So you have to get the next.
I had to get the x alone. Yep. All right, I had,
That's why you have to, we're like kind of like-
it's not 2 answers. One is me setting up the domain, and the second one is me solving for x. Yeah. And the third one is it written in interval form. Mhm. Okay, the test, guys. I have had nobody come to me and talk to me about it being a problem on for your computers. Okay, nobody has come to me and talked to me. So I am assuming that every single person is going to show up to where? Health Science Building where? 104. It's on the bottom floor. I also am assuming that you have attempted to get on Wi-Fi on your computer and that it works. My lab works just fine on your computer on this campus. Okay, you do not want to mess with that on Thursday morning. Okay.